Hello everyone, we are Group 10. Our group consists of 5 members, Abdul, Ali, Ankita, Helen and Jessie. Here we are going to discuss about the site remediation strategies that we have proposed for an abandoned ore processing unit. As we all know, the environment is getting exploited due to the stress from increasing population and urbanization. The impacts are created by the consistent change in the lifestyle of people and the pressure on the existing natural resources. The remnants of historical industrial activities cause impacts to the environment as well as the human life that can impede the further utilization of land. Here comes the importance of site remediation. It is the process of implementing strategies to clean up the environment by removing the hazardous contamination disposed on the land. The remediation strategies can be divided into 3. First one is monitored natural attenuation. The contaminated land will get remediated naturally with the help of indigenous microorganisms. Second one is containment. Here the pollutants are immobilized and reduce the spread of contaminants. The third one is remediation. It includes complete destruction of chemicals. Next, I'm going to introduce our study location. The site has been used for processing of ores and minerals. The unit has different zones for processing of minerals, which includes roasting zone, crushing zone, and waste dumping zone. The site also consists of a laboratory building constructed of asbestos, particularly in the roof. The site has 2 above-ground diesel storage tanks. Moreover, the northwest part of the site was used as agricultural land that is affected by bushfire. Hence, we have found that the location is terrifically contaminated with 4 major pollutants, namely heavy metals, fuel hydrocarbons, asbestos, and ash from bushfire.
I will explain site characterization and risk assessment. There are 4 main polluted contaminated areas. The first one is the ore processing, dumping, crushing, and roasting zone, which includes deposition of heavy metals, particularly lead, arsenic, and mercury in the soil. These heavy metals have severe health effects to human beings and aquatic and plant lives. I have also calculated the risk rating, which is very high, and the strategies suggested for removal of heavy metals are microbial bioremediation, phytoremediation, soil replacement, and thermal desorption. Next polluted area is diesel storage tanks. The contamination of hydrochemicals are found in the soil, which can lead to the ecotoxicity of the environment, can cause green gas emissions, and other environmental problems. The best solution for hydrochemical removals are phytoremediation and bioventing method. Next is the agricultural land of the site, which was used as agriculture land before New South Wales bushfires, and now there's a heaps of ash contamination is found. Ash lead to the soil and groundwater pollution and can cause health effects to the human and aquatic life. The remedies suggested are basically bioremediation and sprinkler system silicon extraction technology. At the last, there is the ore processing lab building and offices, which were constructed by asbestos material, which is very toxic and can cause lung cancer by inhalation to the human beings, and also cause soil and water pollution during the demolition process. So the best possible solution for asbestos control is removal from the site, but the cost of removal must be examined with the consultation team, and extra precaution must be taken while removal processes, as it is very toxic material, and all the safety guidelines must be used.
Hi everyone, I'm Helen Samuel and I'm here to give a presentation on the topic site remediation strategies. Site remediation strategies are the systematic process to detect, assess, and finally eliminate the contamination from the site that has been polluted. It does not aim at entire decontamination, but to bring the contamination level well below the regulatory toxic limit. There are a number of technologies to treat contaminants. Depending on the site condition and pollutants, the site remediation technologies can be classified as chemical, physical, thermal, and biological. So these are the recommended site remediation strategies for asbestos, which includes treatment on site, removal of site, air quality management. And for hydrocarbons, it is in situ steam injection vapor extraction, in situ soil vapor extraction, air spatching, and phytoremediation.
Hello everyone, my name is Ida Saxena and today I'm here to present the site remediation strategies for heavy metals and fly ash. Heavy metals such as lead, mercury, and arsenic was found in the soil. The first method is immobilization. The immobilization strategies are used to prevent heavy metals from leaching into the environment by enhancing physical characteristics of the soil, reducing the surface area across which pollutants can transfer. Immobilization can also be achieved with the help of biochar, which is an emerging technology. Next method is soil washing. The physical separation or the chemical extraction procedures, or a mix of two, are used to separate toxins in the soil from non-contaminated soil particles in this remediation process. Soil washing can be done with strong chelating agents which liberates heavy metal cations from the functional group on the surface of the soil particles. The third method is thermal desorption. Thermal desorption method is based on pollutant volatility and involves heating contaminated soil with steam, microwave, or infrared radiation to make the pollutant volatile. The last method is phytoremediation. So recent research has revealed that removing heavy metals and radionuclides from the soil is more difficult, but they can be efficiently neutralized or transformed into less harmful metabolites. Through their intrinsic catabolic mechanism, microbes are capable of biotransforming, biosorbing, and biomineralizing heavy metals and radionuclides. The next contaminant is fly ash. So fly ash is a byproduct of coal combustion in thermal power plants, and it can be used to generate electricity in a sustainable way. It's one of the solutions. But for the remediation, the first strategy is bioremediation. So fly ash is an ideal soil amendment for plant growth as organic nitrogen and carbon replacement because it contains important macro and micronutrients and has a high porosity. The next method is sprinkler system along with silicon extraction technology. So as the name suggests, the sprinkler system is when landfill controls fly ash, dust, and moisture with misting dust suppression technologies, preventing the ash from drying out and perhaps causing dust to migrate offsite, necessitates maintaining the proper moisture level. Silicon extraction technology is achieved by leaching fly ash with an inert solution containing more than 40% biomass, where silicon is leached from the fly ash in the form of sodium silicate.
Let's first talk about the cost comparison of identified technologies. These technologies have been identified by using literature review. Two technologies have been selected for ash, hydrocarbons, and heavy metals, while one technology is only present for asbestos. So when we talk about asbestos removal, we need to remove 12.8 ton of asbestos from the building material of our site. This would incur a total cost of $201,096. 1% of this cost would be the HEDS disposal cost, which is a discounted scheme by government to dispose asbestos. 23% would go towards the labor cost and 8% would go towards the sampling charges. The rest, all of it would go towards the asbestos certified removal. So when we talk about hydrocarbon pollutant removal technologies, we need to remove a 45 cubic meter volume of earth surrounding the diesel storage tanks, which is polluted by hydrocarbons. We can use phytoremediation or bioventing. Even though bioventing is cheaper than phytoremediation, we would still use phytoremediation because it would cover the other pollutants as well. So the heavy metal removal would need 728 cubic meter of earth with an average depth of 0.2 meter to be treated. Microbial bioremediation would incur a total cost of $29,000, while soil replacement and thermal desorption would incur a cost of $179,728. We would be selecting microbial bioremediation. So when we talk about the ash pollutants on our side, it would be released by the NSW bushfires. We have bioremediation or sprinkler system silicon extraction technology. We would be selecting bioremediation because it would be in line with the technology we have selected for heavy metals as well as hydrocarbons. Would cover heavy metals, ash, and hydrocarbons. Thus, it would save cost and would eliminate the need to select separate technologies for all these three. Asbestos would still need to be removed by the certified removal.
Moving on to the actual site remediation strategy for asbestos. Initially, the collected asbestos from the site is wrapped and contained in a well-equipped manner such that the fibers are prevented from entering the site. Then the wrap material is labeled within the asbestos hazardous symbol. The loading and transportation is carried out in such a manner that the transporting vehicle should always travel in an authorized route. The soil sampling is done from the site by an environmental consultant to identify the risk and the associated impacts. And finally, an asbestos clearance inspection is done for the area and the surroundings for the completion of asbestos removal work prior to normal reoccupation of the site. Actual site remediation strategy for hydrocarbon employ live plants to purify polluted soil, air, and water. Initially, hydrocarbon toxicity and tolerance screening of the potential phytoremediators were analyzed. Isolation and characterization of rhizobacteria that promote plant development and degrade hydrocarbons. Finally, evaluation of the efficacy and effectiveness of microbial-assisted phytoremediation is done. Thank you.
Considering the benefits and costs associated of the remediation strategies, phytoremediation is the most suitable strategy to remedy the land polluted by heavy metals and fly ash. It has been found to be a promising approach and could be improved further through genetically modified plants and microbes. The steps to remediate can involve, first, determining the materials and methods of the soil. What experiments can be conducted to determine the physical and chemical characteristics of the soil, and analysis can be conducted to determine the soil reaction, that is the pH and electrical conductivity. Organic matter in the soil can be measured by using the Gaussian ignition method. But lastly, the Helianthus anus L is a good hyperaccumulator plant used for the removal of heavy metals because of its phytoremediation efficiency. Results have shown that the industrial contaminated soil had a significant impeding effect on the plant list of H. anus as noticed by the reduction in growth parameters compared to the standard. It is proven to be effective for decontamination of highly affected industrial soil. This is my recommended strategy for heavy metals and fly ash. These are a few of my references. Thank you.